Hey everyone, this is Bob the Science Guy. Let me change this mic out and then we're going to sit down and have a look at what's going on with the telescope tonight. Just kind of get a little better sound quality here. Looks like we have a beautiful evening, so I'm probably going to stream for a few hours. Give me a second, let me change over this this mic and we'll see what we can do. There we go. Let's see how that's working. That's a little loud. Let's back that down a little bit. Probably about, right there. Sounds pretty good. You guys have audio out there? Hey, Marcus. I haven't seen the moon tonight. I think it's probably out in the west right now. I haven't looked to see where it is, but I think it's over in the west. I don't even know if it's still up. I haven't even looked that way, to be honest with you. What we're looking at right now is some geostationary satellites. The telescope information is down in the lower left of the screen here. We're using the RASA 11 tonight, and the ZWO 6200 color camera here at Shamrock Observatory in Michigan. It's better now. Audio's good now. Marcus seems to think the audio is pretty good right now. It was originally low, but I think we're at a good level now. Give him a second to respond. There's always that 30-second delay. It leaves me wondering how things are going. I already got a few people watching. Now, I will be taking requests tonight. In case anybody has anything in particular to look at. Right now we're looking at satellites live in orbit. These are geostationary satellites. The name of one of these satellites is Amazonas 5. And it was launched from Russia and Kyrgyzstan back in, I think, oh heck, I don't know. Rather than guess, let's go look. So right here we've got a little bit of information on this satellite. Give it a second to come up. So the satellite itself is Amazonas 5. You can see the altitude right here is about 38,000 kilometers. And it is located right here over the beautiful rainforest of Brazil. And we are seeing it from up here in Michigan in the US. And as you can see, even though these things are only about the size of an SUV, we can very easily see them because they're lit by the sun. Now, the interesting thing about these satellites is these are in geostationary orbit over the equator, and they're normally always sunlit. The only time they're not sunlit is during the equinox, where they have about an hour and a half that they are eclipsed by the shadow of the Earth. So right around the equinox in March and September, there will be a period of time where these satellites are eclipsed. Now, it's actually very easy to track these things because they orbit over a fixed point on the Earth. So all you really have to do is point the telescope at them and then turn the tracking off. The tracking is what compensates for the rotation of the Earth. With geostationary satellites, you don't need to do that because they rotate with the Earth. Their orbital period is exactly the same as the orbital period, or the rotational period of the Earth itself, which is 23 hours, 56 minutes, and approximately 4 seconds. Now, question of the day is, why is that not 24 hours? Anybody have any idea? If you do, put it in the chat and we'll see what we have. I'll put the mic on mute for a couple minutes and what you guys think about that. I'm going to go get myself a little drink. Well, Marcus, of course, that is absolutely correct. The reason the rotational period of the Earth is 23 hours, 56 minutes, and 4 seconds is because that's the time it takes the Earth to go around once. Just make, I'm sorry, I said orbital, I mean rotational period of the Earth. However, we also have to orbit the sun. So even though we've gone completely around in that 23 hours, 56 minutes, we have not gone all the way to point back at the sun. We need to orbit another 4 degrees, or we need to orbit another 1 degree in order to do that. And the orbital time for 1 degree is approximately 4 minutes. And there you go. So again, that's confirmation that we are indeed orbiting the sun, because even though our rotational period is less than an hour, or less than 24 hours, we have to rotate for a full 24 hours to keep aligned with the sun. Now I'm going to do something a little different tonight. I think that I'm going to try and live stream this on TikTok. in addition to doing it on YouTube. So we're going to go see how that works out. Got to get this power up on the phone a little bit today. So we're going to disconnect that from that. Going to bed, honey?
Yeah, good night.
All right. Give me a second. My wife was up a little bit later than normal tonight. She normally works very early in the morning, and I do most of my work at night. And she stayed up a little bit later tonight prior to me starting this stream, and she's just going to bed, and I just want to say goodnight to her real quick.
Hello? Can I speak to Paul, please?
Hang on just a second.
They don't agree on a lot of different topics. This is he.
Sit around here and see what I can do to get this going. Okay, so we're just kind of minding our own business, watching these satellites go. Well, let's see if I can go live with this thing. Should be able to. Well, let's go out here on TikTok and see what we have. Not 100% certain this is working, but we're going to find out. There we go. I think we're live on TikTok now too, which is pretty cool. So let's go see. So we're live streaming the main channel on YouTube. That's Shamrock Bank's Observatory on YouTube. And I also have TikTok going. This is just my spare screen where the telescope is being viewed. So I'm going to kind of talk back and forth, and we'll see what we have. Okay. So let's see, I don't see anybody asking to come up, so I'm thinking that I can probably do multi-guest with this, but we shall see. Tonight we're doing live stream on the telescope. This is an 11-inch RASA telescope out in my home observatory where I study comets, asteroids, and do a little bit of astrophotography, although that's not my main job. These little dots right here that you see are geostationary satellites in orbit, and you can kind of see them right here. Now, I look up the orbital elements of these satellites, and I slew the telescope to them, plate solve, and then confirm that the location is, my telescope is where I told it to be, and that's where these crosshairs are. And as you can see, the satellites are indeed right where NASA says they're supposed to be, which is kind of cool. So I thought I would share this with my TikTok audience a little bit, although the main stream is going to be over on YouTube at the Shamrock Banks Observatory channel, and that's where I'm going to be doing most of my interaction. I'll have a little bit over here on TikTok, but I don't know if I can get these. Let's see if we can get this a little bit better. So there, I've zoomed it in a little bit. So these are the geostationary satellites. There are 3 of them there. And in fact, if you actually reduce the magnification a little bit, see, here's the full screen right here. But if we start moving in a little bit on that, say to 50% or so, you can see that there are 3 geostationary satellites here, but there are also another 4 for a total of 7 that you should be able to see. For example, there's one right there. There is another one right there. So there's 5 geostationary satellites. There's some more down here below. Let's go ahead and turn this off. See if we can spot them a little bit. So what we'll do is we'll go ahead and make this just a little bit brighter to make it a little easier to see. See if we can spot some more geostationary satellites. So there are the 3. There's 4, 5. Is this one here? No. So there's another one there. And there's another one there. Those are the ones that I can see right now, but then again, I don't have my glasses with me. Maybe some sharp-eyed viewers can see them a little bit better. We'll go ahead and give you a little bit more magnification. There we go. So there's 3 there. There's another one over here, see? And then if we move this on over some, there should be another one in trail right there. Okay. See if we can find some more in here. Well, there they are right there. So there's 5 of them. That's probably good enough for right now. Now you can tell that these are satellites rather than stars because notice that the stars are streaked. And the satellites are distinct little points because we're tracking the satellites, not the stars. And what we can do here too is we can make this just a little bit longer exposure, make those star streaks a little bit longer. And you'll see the satellites remain nice little round dots. I think this stuff's pretty cool. So now that we've got a little bit longer exposure there, let me adjust the contrast a little bit. So we'll take this, kind of move that little, move the light curve over a little bit. Make the background a little bit blacker. It's a little green right now because of the light pollution. I live in a small town in Michigan, and even though it's a small town, we still have streetlights and stuff. And that makes it a little difficult. Yeah, I'm not seeing any other satellites right now. I know there's a total of 7 in that area, and I only see 5 of them. They tend to spread out a little bit from time to time. May need some orbital adjustments here and there. But you can pretty clearly see them. So these are obviously very different than the stars in the background. Now, can you guys see that okay on TikTok? Let me go ahead and turn this one light off and we'll see whether or not we get rid of some of that glare. At least a little bit. There we go. Now I can see the chat a little bit better. You guys, if you get a chance, make sure you hit a like, a couple of hearts on this thing, and share it around a little bit. We'll get some people in here. We don't have too many folks here, which is kind of sad because we've got a really nice night for the telescope. But I'll let it run for a while. We'll see how it works. There we go. We get those likes coming in. Now I'm going to go grab my robe because it's going to be a little cool outside in case I have to run out there. Now, one of the problems of running an observatory in Michigan is it's either cold and snowy or it's hot and buggy. I'm in a very fortunate situation in that I have an observatory out in back that's in a dome, so I don't have to set up the telescope every night. Everything's all ready to go. I just have to open up the observatory and get everything hooked up. And I can also run it from inside my house using Chrome Remote Desktop, which is what I'm doing right now. The particular telescope that I'm using is called a RASA 11, and it does not have an eyepiece on it. It's not a visual telescope. It's used only with cameras, and we have pretty much a state-of-the-art camera right now, a ZWO 6200 color camera. And as a result, I don't have to actually physically be outside with the telescope, so I can stay away from the bugs. My friend Marcus got blood sucked out of here, blood sucked out of his telescope tonight due to the mosquitoes, but I'm in a little better position that I can run this from in the house, sit here in the air conditioning, and have a good time doing this. Kind of concentrate on the images rather than concentrate on keeping my hemoglobin up. Hey, Judy. Yeah, probably mercury vapor lights, Marcus. They're pretty common. There is a light pollution filter on this telescope, but you know, hey, light pollution filters are like special fishing lures. Sometimes they catch more fishermen than they do fish, you know. When I put the C14 out, it will have a filter drawer, and I'll have a pretty good light pollution filter on it. So we'll see what happens. Now on TikTok, is the audio coming out, and is it okay? Because I see a lot of people coming in and such, but I'm not seeing an awful lot of feedback from it. I'm wondering if they're hearing silence. So if you do hear me, these are the geostationary satellites here. We'll see whether or not maybe we can get somebody up here. I'm curious as to whether or not I can actually bring guests up on this live.
Hey Bob, how's it going?
Hey Rockadial, how you doing tonight? We're doing satellites. Now,
That's cool.
this is the first time Rockadial is a friend of mine over on TikTok for you guys on YouTube. He is a fellow science educator and all-around good guy. And hopefully he's...
Very generous statement.
And he paid me a shiny quarter to tell you all that. So make sure if you're ever on TikTok, you look up Rockadial and give him a sub. Hey, can you see these? Can you see these satellites?
Are those the stationary dots?
The stationary dots are the satellites, and the streaks are the stars.
That's cool.
Now, just to show you the difference, right now this is the RASA 11, and what I've done is I've turned tracking. Once I got it lined up, I turned tracking off. So these are geostationary satellites, and they stay over the same spot on the Earth. And as a result of that, the way to track them is you literally turn tracking off. But when you turn tracking off, of course, the rotation of the Earth makes the stars streak like this because the Earth is still rotating. Now, if we go down here, see, we'll go over here, we'll turn off satellite tracking for a minute. This is Amazonas 5, by the way. It's over Brazil, about 38,000 kilometers up. So we'll turn tracking off, satellite tracking off, and we'll put sidereal tracking back on. There we go. Now, let's just go ahead and watch this for a minute and see what happens. What's interesting is you'll see the stars now are fixed, and you see the satellites streaking by. So here are the streaks from the satellites. So we've got 5 geostationary satellites here, and this is a 4-second exposure. And we're looking at a field of view here. The total field of view is 2 degrees tall by 3 degrees wide, but we're zoomed in a little bit.
Is this live?
Oh yeah, this is live. I'm doing it right now.
Wow.
Yeah, so here's the full field of view. Now again, you can't see too much because the satellites are down here. You know, that'll give you an idea of where they are. Come on. So the satellites are down here. So if you zoom in a little bit, so you see the satellites are coming through here. Let's turn this off now. Here's where your eyes got to get really good. You see these down here? And then these two? Now there should be 2 more, because this first group normally has about 4, and then there's 3 in trail, and I only see 2. I tried looking for our little interstellar visitor, and unfortunately it was in the trees, which kind of sucked.
G in the comments had a great question that he's talking about critical mass of space debris that can make launches hazardous, and that, to build off his question, are we able to how small does the how small can we track space debris? Like can we, with our sensors, are they fine enough to detect like nails or screws flying through there, or is
Actually, yes. I can't do that, of course. You know, the smallest object that I can track is probably just a little bit under a kilometer. You know,
it's only a little smaller.
yeah. I mean, I can get down to maybe half a kilometer. You know, I can detect an asteroid that's that big. But what they do for space surveillance, the Space Force, what they use is radars. And with radars, you can get really small things and very accurate trajectories and stuff. You know, so if you have a near-Earth object, they're not going to rely on people like me. You know, I pick stuff up that's out, you know, a ways from us generally. When you start getting into near-Earth objects, they're moving so fast, they're difficult to track by telescope, but they're very easy to track by radar. And we not only can get the path, you know, the trajectory and the speed on them, you can actually get some surface detail on them. You know, very accurate measurements and things like that.
Wow.
Is this thing working?
It looks frozen. Are the satellites still in view?
Yeah, they're right there. They seem to be working. Let's go ahead and turn the tracking back on. So we'll start satellite tracking again. Notice that the little circle here is red.
Yeah.
That means that we're not quite on it. Now it's turned to green. That means that we've locked onto it again. So if we put our crosshairs back up and we zoom in a little bit. Dum dum dum.
He's tracking 5 satellites.
Yeah.
Sorry,
Yeah.
Mrs. Crocodile here.
Hi.
Hi, young lady. You keeping him honest?
I try to keep him busy at least.
Well, that's the best way to do. You know, idle hands are the devil's plaything. So basically, you know, to kind of get you caught up since you just came in, these are geostationary satellites. And the way that you can tell that they're geostationary satellites is that I was looking specifically, let me zoom that out just a little bit.
Are geostationary satellites that are anchored to a particular place on Earth?
Yeah, they orbit over a very specific spot on Earth.
And these are the ones you said were over South America?
Yeah, these are over Brazil. So here's 1, 2, 3, 4, 5 of them. Can you see those okay?
Yeah. Well, I can see 2 of them. Okay.
Yeah, I moved it around a little bit.
Yeah.
You should have them all right now.
There we go.
There we are.
4 of them. 1, 2, 3,
Yeah.
Still cut off a little bit, but I can see most of them.
Yeah, that's the problem you run into with this. What I may do is let me go ahead and make this just a hair smaller. Let me shrink it down just a little bit, and then it'll be a little better for the folks over on TikTok. Okay, so those, there you go. You should be able to see them pretty well now. So what happens is, since it's basically tracking the satellites, and as the Earth rotates, the stars will streak like this. And then we see the satellites. And I just showed what happens when you turn off satellite tracking and put sidereal tracking back on. The stars become individual points of light and the satellites are streaked. I do that sometimes when I'm having trouble locating them. Like, for example, there should be 7 here and I only see 5. And I can't find the other 2. So what I did was I turned off tracking for a minute to see if I could pick up the little streaks of the other satellites, but I didn't see them, unfortunately. So we've got YouTube running, and we also have TikTok. The main channel over on YouTube is Shamrock Bank's Observatory. And Marcus over here in YouTube is making mention. He is involved with the Canadian radio telescope projects. And they've got a 47-meter dish out there, and it's used mostly for space surveillance. How small can you detect objects out there, Marcus? He is a friend of mine, does radio astronomy. I think he's over by Ottawa. You know, I may have to have a chat with him when it comes time to do my thesis. I want to do some radio astronomy, so I may talk with him and see if the Canadians will host me over there for a little while. But we'll see. The guys here in Michigan don't seem too interested in it, and I'm thinking about building an advanced radio Jove here at the university, using 4 antennas as opposed to my 2, and be able to detect circular polarized radio bursts from the sun and from Jupiter. Do some actual research with it.
And so you said these satellites are currently over South America. So are you?
Yeah.
You're using which telescope are you looking at them through?
I'm looking at it through the RASA 11, and if you want to see it, so here's the observatory. You see, here's the aperture of the observatory. Here is the top rail of the telescope, and it's an 11-inch telescope. The camera's out in the front of it because it's not a standard telescope. It's something called an astrograph. It's a Rowe Ackerman-Smith astrograph. That's what RASA stands for. That means that it doesn't have an eyepiece on it. Now, when I upgrade next month to the Celestron C14, and it'll also have what's called a Hyperstar on it, which is going to turn it into basically a 14-inch RASA. I'm going to really be able to get some impressive stuff. But more importantly, I can take the Hyperstar off, use it as a regular telescope, and it has like a 4-meter focal length, which means that I'll be able to get really good detailed images of the red spot on Jupiter and Saturn's ring and the Cassini divisions. And we'll actually be able to look at the structure of the craters on the moon. So we'll be able to look at different types of craters, because some are smooth, have smooth walls, some have stepped walls, and a central mountain or a central peak. And we'll be able to look at that very closely. My goal is to be able to see the Armstrong, Aldrin, and Collins craters near the Apollo 11 landing site. Yeah, Marcus says that they're doing 3-centimeter wavelengths, which is 10 gigahertz. And, so you're looking at something that potentially could see something as small as 3 centimeters.
That's incredible.
Well,
That's incredible.
I'll tell you, the Canadians are really good with radio astronomy. We're good with radio astronomy. The Chinese and the Russians are. And I'll tell you, though, the guys that just do their thing with it are the Australians. They really do a great job of radio astronomy down there. They were the ones that brought us the moon landing images. During a typhoon, I might add.
Wait, so they were
Yeah.
60s and 70s? That was Australia did that?
Yeah.
Oh, wow.
No.
I think it's amazing that you're up in Michigan, and you're able to see these satellites that are over South America, over Brazil.
Absolutely.
That's
Easily.
wild.
But, you know, I mean, they like to say that how can you do that? It's so small. Well, there they are.
And
Yeah.
You can only see them, though, because they're still catching sunlight? Or
Absolutely. Yeah, they're 22,000 miles high in their orbit. So the only time that we lose sunlight on them is when we're at the equinox. So, well, I mean, this is kind of cool, to be honest with you. Let's go find some other cool stuff to look at. So, these are all the satellites that I can hit. So these are all geostationary satellites. I can also pull up GPS satellites. I don't really have the skill and the capability to hit low Earth satellites. You know, like these guys that get 14-inch telescope images of the ISS and see people on spacewalks and stuff. I don't have the skill to do that yet. You know, because they kind of rip along the sky. But there are people out there that do. Astronomy Live is one of them. Where's Andromeda right now?
Naked.
Huh? So what we're going to do now is we're going to go on over to Andromeda. So you see, I'm telling the telescope to slew over there. Daniel Webster, I like squirrels. I like squirrels too. I used to have a pet squirrel named Hugo. My brother lived in Charleston during Hurricane Hugo, and he lived on those barrier islands out there. So after the hurricane, I drove up from Florida to go help him out a little bit, bring him a generator and things like that. And we were cutting down this tree, and this baby squirrel jumped out, landed on the shoulder of my Army field jacket, and ran down the sleeve and crawled into the pocket. And being a relatively bright person, I decided I didn't want to reach in there and try and pull him out because he still had teeth. But I figured if he stayed in there by the, you know, for the whole time that we were doing this and we were done, he was going to be mine. So that's how I got my little pet squirrel Hugo, and I had him for years and years. All through med school. He was a great pet.
Oh, wow.
So, now let's go sit down and see what we can do with this. There is Andromeda.
Oh, wow.
And, oh, no, we're not wow yet. Trust me, this is not wow. I will show you wow.
Okay.
All right, so the first thing that we're going to do is we're going to do something called plate solving.
What did you say it was called?
This is called plate solving. So the telescope's going to take a picture of the star field here, and it's going to compare it against the maps. And it's going to sit down and say, well, I know you're supposed to be here, but we're actually pointing here. And as you can see, I'm probably 1.3 degrees off. So what it'll do is say, okay, well, now I know what I'm looking, you know, and now I know where I'm pointing. I'm going to go point where he told me to go. And notice now Andromeda is directly in the center of the field. Now, the next thing that's kind of interesting about doing this sort of stuff is we do something called guiding. So I'm going to turn the guide camera on. Now notice that I see some stars in this little telescope. So that was a different cat, Judy. So it's picked a star, and that's this one down here. And what it's going to do is it's going to lock on that star. So it will sit down and keep the telescope locked on that star. So now that I'm guiding right against this, what we're going to do is we're going to do something called live stacking. And we're going to go here to M31 is the name of this. And we're going to change this on out. We're going to drop out that light curve a little bit, and we're going to go from I don't know. What is this? I think that's it. Does that look like 90 seconds there to you?
I can't see anything.
All right. Well, it's right there. I'm thinking it's 90 seconds. It's looking pretty good. And then we're just going to hit live stack. Boom. Now.
It was a 90-second exposure.
90-second exposure, yeah. So now what we're going to do is we're going to sit down and chill for a minute. And got 8 people over on YouTube right now, which isn't bad considering it's the middle of the night. Judy keeps wondering if she's hearing Otis, my cat, and I think what's happening is she's hearing your cat.
Yeah, we got
And-
our back.
We have a very vocal cat.
Yeah, is it orange?
No, we do have one. We've got 5 cats. This one's a tuxedo.
Oh, okay. Well, Otis is an orange tomcat that wasn't fixed until he was an adult, so he's got those tomcat jowls. And he is the mayor of the park here in town. Last year at Halloween, you know, we get all the kids trick-or-treat over at the house because, you know, we're one of those houses that kids come to.
Never get trick-or-treaters of such a list because
Yeah, we get a lot of trick-or-treaters because, you know, this is the part of town where the doctors and the lawyers and the Indian chiefs live. So everybody and their brother comes over here to trick-or-treat. And, you know, they all come up to the house and then Otis is sitting out there holding court. And he goes, "Is this Otis's house? I know Otis. Yeah, I play with him all the time." So every
It's really funny. I went into the Dollar General today, and there was a dog laying on the floor, and I was like, "Charlie?" And it's this dog that
Charlie was in the Dollar
Charlie was in the Dollar General.
yeah.
It's this dog that runs up and down our road that everyone knows. I don't know the
Yeah.
names of people Charlie lives with, but I have his family saved in my phone in case I run into him.
We had to have a tag made for Otis that says, "My name is Otis. I am not lost. I will play with you, but I will go home." So, okay, so here's the first image that we got. Now notice these curves down here. Okay? Here's the, you know, the red, green, blue, and the luminance curve. Notice they don't line up. That means this is not white balance. So if I hit white balance on here, what happens is now it lines up and now it's properly balanced. However, we're not seeing much detail because, you know, I mean, we want to bring this up a little bit and we want to do a few other things. So what we'll do is we'll go ahead and balance it that way. Okay, that doesn't look too bad. We want to get a little of that flare gone, but still keep a little bit of the detail.
That was just a 90-second exposure got that.
That's one image.
It's beautiful.
So now what we'll do is we'll go ahead and auto hide that. And we'll also boost this up just a little bit. We'll make it a little larger. So here's the first image of Andromeda. So you see the core of the galaxy where the black hole is. Hey Judy, thank you very much for the donation. Marcus has his orange cat Ziggy. These are called dust lanes. And if you look around a little bit, that's M110. That is another galaxy. And there's a third galaxy right there. That's called, and this is M31, that's M32. But what's interesting about this, and you don't see it very often, if you look at M110 up here, it's a spiral galaxy. And you can see the spiral arms on it. Normally it's just kind of a smudge, but you're starting to see a little bit of the spiral arms and it has its own little dust lanes on it. Now the thing about Andromeda is it is enormous. A lot of people don't realize how big it truly is. If you could see this with your naked eye to this level, rather than just the core, it would be 5 times as wide as the moon in our night sky. So we're talking 1 trillion stars, as opposed to about, oh, I forget right off the top of my head, but I think it's between 400 and 600 million stars for the Milky Way. It's the big boy of our local group.
I thought the Milky Way was. Well, what about the Isn't the Triangulum Galaxy also close by?
Yeah, that's in our group as well, and that's about the same size as the Milky Way, as I recall. Now, what this is doing right now is it's called live stacking. So it's taking 90-second images, one after the other, and it's layering them one on top of the other. It's lining up the stars. And as a result of that, notice that the background is already getting a little more uniform and dark as opposed to being kind of grainy.
Yeah.
Okay, so what happens is that's noise. And the way you get rid of the noise is your camera's cooled. You know, you chill the camera down to minus 20 centigrade. And you also stack, so you know the noise from one image tends to cancel out the noise from the next image because it's more random. So if you take a bunch of images, you can get rid of a lot of the noise. So there's 3 galaxies right there. There's M110, there's M32, and M31. The thing that always blows my mind about this is if you look at the odds, there are probably 20 civilizations that we're looking at right now that are probably looking back at us.
Wow.
You know, have the capability of looking back at us. And there's some astronomy club on a star right there that's talking about the Zog, which is, our Milky Way, and wondering whether or not there's sentient beings here looking back at them and what they're like.
It's a really beautiful thought.
Yeah, I get deep once in a while. Even a blind squirrel gets a nut sometimes. You're a mod on this channel, aren't you?
Me? No. This is the first time I've actually been on your channel. I did not,
I don't do many live streams, to be honest with you.
Yeah, I thought you mainly did them on YouTube. That's why I was surprised when I saw your name pop up. I was like, oh, I didn't know.
Yeah. Marcus is making a, he's commenting the central limit theorem is doing its thing. Same as in radio astronomy. That's a calculus joke. Well, it has to do with the noise canceling itself out. That's what he's referring to.
Well, I'm gonna turn in. Thank you so much for having me up here.
Oh, you're very welcome. Like I said, I may do more of these. They seem to be working out okay. You can see the stuff okay?
Yeah, I can see it. I'll take a snapshot. Next time you're on one of my lives, I'll pop it up so you can see what it looks like from my end on TikTok.
Cool. I'm looking at it here, but you never know what the quality is over on yours.
It is hard to tell.
Yeah. If anybody else wants to come up, you guys are more than welcome to come up. Here, it says, and I should invite this one here, so let's give that a try.
Yeah, I'm gonna drop down. Thank you so much, Bob. I'll talk to you later.
Good night.
Take care. Good meeting you, Mrs. Rock. It's just so difficult to read the comments while I'm doing this. So what this is doing is this is just stacking images one right after the other. And with each stacked images, it'll just get clearer and clearer. Guys, make sure you hit that like and make sure you follow me. And if you get a chance, go over to Shamrock Bank's Observatory on YouTube and you can see the actual live presentation there. It's a much better video quality. We're getting a few people coming over here. So for you guys on YouTube, this is the, of course, Andromeda, our galactic neighbor, and the farthest object in the universe that we can see with our naked eye. Most of the stars that you see in the night sky are in our arm or the next arm of the Milky Way. This is another galaxy, actually 3 of them. The main one here is Andromeda. This is M32 and this is M110 up here. M110 is a spiral galaxy. I'm not so sure about M32. But we're looking at that, and that is 2.5 million light years away. And we can literally see the core of this galaxy from in a dark sky area with our naked eyes. It's very easy to see with binoculars. And as I was mentioning earlier, if you could see to this level of light, this would be about 5 times the width of the moon. Now I'm going to see if I can adjust this, make it a little bit brighter without blowing it out too much. There, that's a little better. We'll give that a try. Now, one thing that I would never claim is I am not an astrophotographer. I can take snapshots of the sky, but I'm not into these beautiful, artful photography. The beautiful, artful astrophotography that you'll see sometimes. What I do is I basically look for little dots and then I track them and calculate their orbits. I mostly work with asteroids and comets. But every now and then I like to do outreach where we just have a look at some cool stuff that we can see with a telescope. As you can see from the bottom, this is a RASA 11 telescope. It's an 11-inch telescope designed for astrophotography. The camera is a ZWO 6200, which was donated to the channel, and it's a color camera, and I use that for my work with the Minor Planet Center looking at asteroids. But it does take pretty nice pictures every now and then too. It's a little glary here in the center. I don't quite like that, but let's see if we can ease that out just a little bit. Yeah, it didn't like that, did it? We may have to just deal with that. That would be one of those things that you would clean up a little bit in post-processing. But overall, it's not too bad. We're also dithering here a little bit, which means that every third or fifth image, the telescope will move just very slightly. That cuts down on artifact, and it also cuts down on background noise. So it's pretty cool. Still getting pretty good audio out there on YouTube. Yeah, Marcus brings up a very good point, which I noticed with visual astronomy. So for example, if I want to take a picture of Jupiter, there's a couple of things that are of interest in Jupiter. One is the surface detail, and you want to see the atmospheric striping, and you want to see the red spot, for example. And the other thing that it's got a series of moons. The problem is if you get enough exposure to see the moons, Jupiter itself is blown out. If you reduce the exposure so you can see the detail on Jupiter, you can't see the moons. However, with your eye, you can see both at the same time. But then again, Jupiter is very bright, and there's plenty of light for you. The eye requires a lot of light to see color. So if you look at things like the Great Orion Nebula, that's got a beautiful red color to it, and that's its actual color. However, if you look at it with binoculars, you can see it, but it's in black and white because there's not enough light coming from it to stimulate the cones in your eyes, but there is enough to stimulate the rods, and the rods give you black and white vision, and the cones give you color. So those of you that have been deer hunting, for example, or been out, just before dawn, as the sun is coming up, the first thing that you start seeing when you start seeing any detail in the woods or the trees or anything, you see things in black and white. And as the sun comes up, color starts easing its way in. Very fascinating thing. Now, Marcus, are you getting a little music in the background too? Is the music there, and is it at a good level? That's the question. Okay, so I don't see any people requesting up on TikTok. It is open for if you want to come up and chat. I do accept invites. Make sure you hit those likes and follow the channel. And for those of you on YouTube that have not subscribed to my channel yet, go ahead and do that. It doesn't cost anything. It just gets you notification when these things, when I do the live stream, which I try and do pretty much every time the sky is clear here in Michigan, which isn't all that common. You know, not as often as I would like. I wish I lived in Arizona on a mountaintop somewhere. But, you know, the family and the work's here, so this is where I am. I've got Bortle 3 to 4 skies here in this small town in Michigan. And as you can see, I can see some pretty decent things. Now, we've had a look at Andromeda for a while. I'm wondering if we might be able to find something else out here. So let's go ahead and clear this off. And we're going to go back down here to Sky Tracker and see if there's anything interesting. Now, one thing that I can do, I'm going to download comet orbital elements. So that's a magnitude 16 comet. It's only 13 degrees above the horizon in the southeast. We'd like something a little higher. That one there is probably not too bad. We might be able to get that one right there. So let's go ahead and have a quick look at that. I am going to go ahead and make this 100% again. Make that auto. And we're going to change the exposure over here to 4 seconds again, which I think is about right there. That looks about right. Alright, so we're going to go ahead and see. We got some stars. Okay, that's tracking. That's good. Well, I'll tell you what, let's use a little different program for this. So we're going to turn the camera off there. I'm going to go over to a program called Nina, which is what I run my observatory with. I'm going to turn the camera on here. Let me turn the cooler on as well. We're going to go on out here and just have a quick look and see where we are. We shouldn't still be pointing at Andromeda, but let's go see. Now, as you can see, the telescope is slewing over to where I told it to go. And the dome should rotate so that the opening in the dome is in front of the telescope. It's not doing too bad of a job. Oh, one thing I do want to do is turn off tracking. That's probably causing some heartache there too. So let's clear that. Okay. Now, getting some nice stars there. Let's take it over to plate solve. See if we can figure out what we're looking at right now. Yeah, I'm kind of spoiled. My telescope tracks pretty well, plus I can guide. So you see, it said I wasn't quite where I was supposed to be, so it is recalculating and doing it again. And now it's happy with where it is. So we should be pointing directly at the comet right now. So what I'll do is I'll go back over here to imaging, and we're going to turn on imaging. I'm probably going to give about a 15-second exposure, I think. We're going to see if we can find a comet here. So right now it's imaging. You can see the progress of the imaging right here. And there should be a comet right there at the crosshairs, or very close to it. So what we'll do is we'll let it finish processing and stretching and everything, and then it's going to put out an image here in just a second. That looks like it's the first image. Let's see, we got a comet around here somewhere? That bright star there may be one. I'm looking for one with a tail though. Yeah. Let's go see, what was the magnitude of that comet? 16.7. It's kind of dim. If you guys want to see these things, I'd probably want to get one that was a little bit better. So there's one that's 15 too, but it's only 14 degrees above. Ah! I'm looking at this one. I'm impressed with this one. Not impressed with the fact the mount didn't move. Sometimes we have to stop it. Now it's moving. So let's go see if we can get a little better shot of this comet. This is a little bit higher in the sky, and it's also pointed away from town. So, you know, it's kind of heading over towards Hamburger Hill, but still might be a little less light pollution in this general direction, northeast of me. Boy, that's a big-ass spider, isn't it? See the spider right there? I'm probably going to adjust this dome over a little bit, but let's go see where we are. See what it looks like. So let's stop that. Do another quick plate solve and see what we got. So it's taking an image and it's trying to solve. It's not quite there. Generally it's about a degree off when I do a slew, and that's pretty common. So it's adjusting, and it's let's see if it's happy with that. Looks like it is. So there's probably a comet in there somewhere. So what we'll do is we'll go back over here to imaging. You know, that was just a couple of seconds. This one here is a 15-second image. We'll see if we can get something a little bit better with this. So here's the bar right down here that tells us how far we are in the image and what it's doing. So right now it's processing that image, and we'll see what we get. This comet's bright enough we should be able to see it. It's 15. Okay, so we've got good stars here to track with. I'm going to track with that. And I'm going to go ahead and I'm going to stop this. And I'm going to move this up to a 90-second exposure. And we're going to see whether or not we can see some stuff here. If it's got a tail, it'll be obvious at 90 seconds. Thanks for the likes, guys. Everybody see okay? Out there in TikTok land? I know YouTube's looking pretty good. So you see, here's the progress of the image down here. You see this bar? When it gets all the way over here to the right side, that means that we've completed the image. Take a couple of seconds to process it, and then we'll see the next image. If we do get one, I think I'll probably image it over on SharpCap, just because it's a little better for those types of images. You know, if I'm just looking at the core to calculate its orbit or something or other, it's just fine to do it here. Well, that is not doing 90-second images. That's doing 15-second images. Let's try that again. There we go. Let's see if we can get a little longer image here and see if we can find us a comet. Like I said, it should be within these circles right here. I don't think it'll be, generally I'm not that far off. It's generally right in here. This is the controller for the telescope. It also does things like the dew heater and my environmental sensors. So as you can see, 90% humidity, ambient 16 degrees Celsius, dew point is 14 degrees Celsius, and it's putting out almost 30 watts, keeping this thing dew free, or almost 40 watts. So we're right near the dew point, which means that we got to be very careful with our dew control systems here. The dew control system is a ring that replaces the retaining ring for the corrector plate on the telescope, the big glass plate in the front. It's got a copper internal side, and that copper heats the corrector plate, you know, like a hot plate, and warms it up and keeps dew from forming on it. Okay, we should have that first image coming out now. Come on, process. The other way, if you don't see the tail, the other way that you can find the comet is that if you do a live stack on it, you'll see the comet actually move across the screen and the other stars will be stable. Tracking is excellent. Looks like an arc second or better. Now, I don't see anything in here that really looks like a comet to me, which is strange. Tell you what, let's take a moment. Let's just autofocus this again. You know, just check the focus on this, and then we'll flip over to SharpCap and see what it looks like. Now, the way autofocus works is there's an electronic focuser on the telescope that kind of moves the knob just like, you know, you normally would. But what it'll do is it'll sit down. Ooh, that's not good. Hang on, I just noticed my battery's almost dead. I think I forgot to plug it in over here. My apologies, folks. I thought when I moved this thing over here, I brought the charger with it, but I didn't. So let me get this before this goes down. There we are. All right, we should be working now. All right, so back to autofocus. What it's doing is it figured out where the focus was before, and then it moved it off of focus. So that's why it's way up here. Now it's going to move it down through focus, and then it'll get to the lowest point of focus here, which is going to be right around 1.5. And then the focus will start getting worse again like that. You'll get this V-shaped plot. Well, optimal focus is where it's at the lowest point. And what it's doing is it's trying to figure out where that lowest point is based on the other points. So it's basically drawing two curves and seeing where they intersect. So you can see that it's going to be a little bit off. It's a little bit more over this way than where it was, which is where the red is. So we were just very slightly off of focus. RASAs are notoriously difficult to collimate. Because their tolerances are so tight. They're precision instruments. You know, they're a challenging telescope for an amateur, but doable. The sensor on the camera has to be flat to the main path of light to within a matter of 7 microns. And mine is generally right around 3 to 5. So you can't, you know, and if you don't have it flat like that to the path of light, it won't focus very tightly. So with a RASA, total focus of around 1.5, half flux radius, HFR I think is what they call it. So now it's calculated the best focus, and notice it moved to that, and even though this is way out in the corner, it's still pretty good focus. And if we go to the very center, we should have some rather impressive focus in here now. Now what I'm going to do is I'm going to maximize this up and see whether or not we can get some really good. See if we can see this comet. I don't see any hairy stars there, do you? Notice this graininess in the background. This is noise, and it's generally related to heat in the camera, which is why these astronomy cameras are cooled. These CCD cameras. That might be a little suspicious right there. Just because it's a comet doesn't mean it's, you know, always got to have a tail. It depends on how far it is from the Earth or from the sun. But that one there might have a little something on it. We'll see. You know, but there are other ones that kind of look like that. So let's turn the camera off on this. So we'll go here. We'll turn this camera off. And we'll turn it on over on this one. We're going to sit down and see what we can do. Maybe find some cool stuff here. So that's taking an image right now. C14 E2. So that means this comet was discovered in 2022 by the Atlas survey. And it's got a designation of E2. So let's go up here, we'll call that C2022 E2, and we're going to do live stack. Okay. Going to hit auto hide on this. Get ready for that first image to come out. So here's the little bar right down here in the corner. I don't know if you can see it. I don't think you can. But that'll give you an idea of how long we have. So I think what I'll do is I'll go ahead and stack this one. Well, you asked about it, so you volunteer, my friend. There you go. Okay, so here's our first 2-minute image. We're going to go ahead and white balance it to bring all of these curves in together. Like so. Just making a couple of quick adjustments right here. Okay. Yep, that's it right there. That, I'm pretty sure, is a comet right there, because you can see a tail going up in that direction, see? So I'll put the crosshairs right on it for a second. All right, so that's where it is. Now let me turn these crosshairs off. And you notice right there that has a little fuzziness around it that the other stars don't. But it took a 2-minute image to do it. Okay, we're tracking well here, we're guiding. So what I'm going to do is I'm going to let this take a few images because I suspect that that's the comet right there. And what I'm going to do is I'm going to so I'm going to put that right next to it, actually a little bit below it. There, let's just stick it right there so we can kind of keep an idea of where it is. But let's watch that for a couple of minutes. because that's right where it should be. See? You know, the computer thinks it's going to be right there, but that's right next to it. And, you know, the pointing capability and plate solving capability of this is not perfect. And that very well may be exactly where it's supposed to be. So let's take some images of that and see what happens. Yeah, apparently they wanted me to close it on TikTok because I wasn't as active there as they wanted it to be. But I'm going to keep it going over here on YouTube. This is where most of the activity is, and where my streaming is done is over here on YouTube, because it's just a lot better platform to stream this sort of stuff. You know, you kind of do it half-assed over on TikTok. I'm going to get a few images of this, let it run for a few minutes, just enjoy the music for a couple of minutes, and then we'll come back and have a look at it in a few. Okay, let's go see what we've got here. See, with the time-lapse images, notice that that one there is kind of getting elongated. You're seeing some of that with the others, but that one's much longer. That may be the comet right there. I'm thinking that's the comet right there. That's the other way that you can tell, is they're moving. The other stars are drifting just a little bit, and I don't know why. Is this not tracking? It is. Looks like it's tracking well. But that definitely is moving at a different rate than the ones around it, so that's probably the comet right there, and it's just not got a tail. Yeah, Judy, the stream ended on TikTok, unfortunately. But you can definitely see that that one right there is a little different than the ones around it. I know the polar alignment on this is sub 10 arc seconds, so we should be in pretty good shape with it. But yeah, that's definitely a comet right there. That's moving compared to the other objects. Let's see if this one here makes it a little bit longer. So it's processing the next image. Okay. So I've done a few images here tonight. We've looked around at a few things, including satellites, etc. I'm going to go ahead and shut the live stream down, and I'm going to do some scientific images of this comet, track its orbit and such. To do that, I'm going to go back over to Nina. I'm going to take 40 2-minute images, and then I'm going to process it. And I'll probably do a little follow-up maybe on Sunday to show the results of this, to see how it looks. Just make sure that we got that comet, because that's where it should be. And that thing definitely looks like it's elongating compared to the other ones. So we got us a comet tonight. Now notice too, this is one of the reasons we're getting the C14 for small objects like that. That is the total field that I'm seeing. The comet is right there. But you really have to zoom in a lot to see it, and you're only looking at a tiny little part of the image. Now, when I use the C14 for this and another camera, this area right here will be the whole screen. So we'll be able to get a lot more detail. All right, folks. Let me go ahead and shut this one here off. I'm just going to turn this one off completely. We'll go back over here to Nina. I'm not going to bother changing the stuff here. But what I am going to do is I'm going to change the name to this comet, just to make sure that I've got it. 47p is what I want. I'm not going to have it slew. I am going to have it continue to track. It'll do a repeat focus every 10. It'll dither every couple as well. So we'll go ahead and start doing that. There we go. Okay, we're going to get some scientific images. Alrighty, so now we're imaging. Okay, we're going to get 42-minute images. I'll just make sure that this first one comes through okay. And then I'm going to go ahead and shut down the live. I am going to go over to Discord, I think, and I'll go ahead and just let this run over there. But we've been doing this an hour and 40 minutes, so we should be in pretty good shape. See what this first image looks like. You're very welcome, Judy. I hope you enjoyed it. We got a few nice targets tonight. And I showed you how to kind of tease a comet out of the background. Looks like it's doing an autofocus right now, which is good because it looks like it's off a little bit. Now we'll just let it run. You guys have a great night. I'll start this up over on Discord, and we'll call it a night.